Hello everyone. Now we will continue our learning on reservoir simulation. And again, we will learn to perform simulation using simplistic reservoir simulation with MBAL software. And in this case, we will construct gas reservoirs, one reservoir connected with the aquifer, and the two gas reservoirs are connected with transmissibility. Okay, so we are now inside the MBAL. Okay, and then so we go to tool and then material balance. We go to options, reservoir fluid, change to gas, tank model, change to multiple tanks, no abnormal pressure, production history by tank, compositional model, none. Click OK. Go to PVT, fluid properties. Okay, I only have one set of PVT data. The gas gravity is 0.671 and the fluid is obtained and tested in separator pressure 0 psig atmospheric condition, and we obtain condensate to gas ratio 0.1 stb per mmscf, and the condensate gravity is 49 degrees API, and we measure the water salinity of 21,000 ppm. We don't have hydrogen sulfate, but we do have CO2 of 2.82%, whereas the nitrogen is quite high, 19.92%. And for example, we don't have laboratory data to be matched with the correlation. So we will skip this matching section and we just select the correlation for gas viscosity to be Lee et al. Okay, we can click validate and click done. Okay, so now I will construct the first gas reservoir. I go to this one, double click. Okay, tank parameters, I will call it gas 1, first reservoir gas, and then the temperature 152.25 degrees Fahrenheit, and initial reservoir pressure 1724, porosity 0.26, and Connaught water saturation 0.66. Okay, quite high, very high. And then water compressibility, we will use correlation, original gas in place, for example, 15,000 mmscf, million standard cubic feet. And we will later perform regression to obtain the correct original gas in place. And the start of the production is 18th of December 2005. Okay, the PVT, will use this PVT01 dataset. And let's say initially I don't know whether I have aquifer, so I will skip this one. Raw compressibility, we will use this correlation. Okay, automatically calculated by the correlation available inside the MBAL. No raw compression issue, and then we need to input the relative permeability. The residual water saturation 0.66. Okay, and then the endpoint for the water 0.8. This is the maximum relative permeability of water. And then the exponent 1, and the gas residual gas saturation 0.2, for example, with the endpoint 0.6 and the exponent 1. So if you plot, it will be like this. Okay, so this is the red line is for gas, relative permeability for gas versus gas saturation, whereas the black line with black dots is the water relative permeability versus water saturation. So if you plot them versus water saturation, so you will select this one. Okay, because the exponent is 1, so we have straight line like this. Okay. All right, so far so good. Now I need to input production history. Okay, I have my production history on my spreadsheet. I will copy and paste the data here. All right. So I've copied my data and then I will paste it here. All right, so this is my production history. From the first tank, I have reservoir pressure, cumulative gas produced, and then cumulative water produced, no gas injection, no water injection. So now we can plot. All right. So this is the data for reservoir pressure and for the cumulative gas production. Okay, I can close, done. Now, as usual, we will perform history matching. And you can see the current condition, the initial condition, totally doesn't match. Okay, totally doesn't match.